All right. Welcome, everyone. Thank you for joining us for today's session in our continuing DevSecOps web series. Before deep diving into the topic and letting you know what's the topic is and who is the speaker, let's just quickly recap what we have covered so far in this series. The DevSecOps web series started with exploring how to shift left and integrate security early into the development pipelines. Then, in the next session, we discuss security as code and how to embed security checks into infrastructure as code. And in the last session, that is the third one, we talked about securing containers and Kubernetes in a DevSecOps pipeline. And now here we are moving into the another mission critical topic, that is managing secrets and credential into a DevSecOps environment, focusing on how to securing them without impacting the delivery speed. And to guide us through this topic, we have our speaker, that is Mr. Rohit Kaur, an expert in DevSecOps and cloud security. But before handing it over to Mr. Rohit, as usual, two things to notice. Number one, that this session will be recorded for the future references. And number two, that if you have any questions throughout the session, please type it to the chat and we will take it in our Q&A session. So without further delay, may I request Mr. Rohit to take over the stage? Thank you.
Thank you, Risha. Good afternoon, everyone, and thank you for joining today's session. Today, we are diving into a critical topic, managing secrets in DevSecOps environment. As development, security, and operation team increasingly collaborate, securing sensitive information like APIs, keys, passwords, and tokens that become absolutely vital. So, in this session, we'll explore best practice, essential tools, effective strategies to ensure secrets are managed securely without slowing down the development pipeline. Let's understand how to build a seamless and secure workflow that empowers teams while shielding our system in costly breaches. So let's get started. Now that we have set the stage for our discussion on managing secrets and credentials in DevSecOps environment, let's walk through whatever we are going to cover today. First, we are going to look the real world breaches that are caused by secret exposures, powerful reminders of why these topics matters. Next, we'll dive into the growing importance of secrets management in DevSecOps, where development, security, and operation intersects. We will then explore the risk of poor secret management, from security gaps and downtime to non-compliance. From there, we'll go deeper into the types of secrets, their life cycle, and how they should be handled in environment like containers and Kubernetes. We'll also uncover the policy enforcement techniques, industry's best practice, and trusted tools to help you secure secrets across workflows. This roadmap will guide us through the critical component of secret management, not just the theory, but we'll see some live examples as well. So, brief about me. I'm Rohit Kaur, a cloud DevOps lead at Cloud Techner, specialized in cloud architecture, automation, and efficient deployment strategies. We are committed to deliver scalable, secure, and innovative cloud solutions that drive business success. If you'd like to contact, there is a LinkedIn link in the slide. You can follow that. So now let's dive some into the some real world examples that shows how damaging secrets exposures can lead organization. These cases will help us understand the real consequences from data breaches to reputational harm and why proactive secret management is not just important but an essential part. So let's look at some high profile real world cases that reverse the serious consequences of secret exposure. The first is Norton LifeLock. Around 9 lakh 25,000, 25 lakh, 9 lakh 25 accounts were target due to compromised credentials. This breach emphasized the danger of credential use and lack of monitoring. Then we have LastPass. in 2023. This breach exposed encrypted vault data and API keys, impacting a significant portion of around 30 plus million users. It highlights the risk of third-party integration and credential isolation. Then we had Twilio in 2023 again. API keys were leaked through a social engineering attack on employees, affecting thousands of customers. This shows how employee security awareness and MFAs are critical. Then in 2024, we had GitHub. Thousands of public repositories accidentally exposed secrets, potentially affecting thousands of organizations among 100 millions of developers. So it reinforced the need of automating secret scanning. Then in 2024, we had Google Cloud. Misconfigured IAM roles, exposed secret account keys, impact tens of thousands of cloud resources and customers worldwide. It underscores the importance of strict access control and auditing. Then in 2023, again, we have Mark and Spencer, which experienced a cyber breach that exposed customer personal data. This highlights how crucial it is to protect secret in retail environment where customer trust is paramount. These incidents makes one thing clear. Proper secret management isn't an optional, it's an essential for safeguarding data and managing user trust. So from these real-world breaches, several critical lessons come into focus. Lessons that every DevSecOps team should take seriously. First is hard-coded credential. Storing secrets like APIs keys, database credentials directly into source code makes them easy target, especially in open source or version controls environment. Once exposed, attackers can gain full access instantly. Then we have credential reuse. Using same credentials across multiple systems opens the door to credential stuffing attack, where a single leaked password can compromise an entire ecosystem. Then comes weak storage practices. Storing password without proper encryption or hashing exposes them to any attackers who gain access. Plain text or weakly hashed credentials are good as compromised. Then comes the non-human identities like service account, automation scripts, API integrations often have high privileges. These non-human identities are frequently overlooked and can become silent entry point if not managed properly. Then comes exposed databases. Unprotected and misconfigured databases have led to some of the biggest data leaks in recent years. When secrets aren't managed properly, entire dataset can be accessed by malicious actors. So these insight reminds us that secret management isn't just a technical task; it's a core part for maintaining trust, resilience, security in modern DevSecOps pipeline. So, as we have seen the risk, let's discuss why secret management is not negotiable in any secure DevSecOps environment. First is enhanced security. Proper secret management protects against unauthorized access, helping prevent leaks of sensitive credentials like API keys and tokens. Then we have regular compliance. It helps organizations comply with security framework and regulations like GDPR, HIPAA, PCI DSS, avoiding legal and financial penalties. Then comes automation. Secrets can be securely injected into CI/CD pipelines, allowing them to move faster without compromising safely. Then we have auditability, accountability. Tracking the use of secret enables us to log, review, and audit fast incident responses, ensuring transparency in how secrets are accessed. Then comes the rotation and revocation. Tools allow us to automatic rotate and revoke the secrets, reducing minimal errors and minimizing the attack of surface. Then comes consistency, whether it is development, testing, or production. A robust secret management system ensures uniform handling and protection of sensitive data. So, I mean, we can say together these benefits make secret management a cornerstone of any secure, scalable, or modern DevOps practice. So, for we have looked like what is the importance of why secret management is plays a vital role. But what is the risk of improper secret management? Can anyone tell? Okay, so I mean, so let's see like what happens when secrets are improperly managed. So I mean, secrets are the keys to your kingdom, and losing control over them opens the door to serious consequences. So we have data breaches. When secret leaks, unauthorized attackers can gain direct access to sensitive databases and internal systems. These often result in massive data breaches where customer data, intellectual property, or property code can be stolen or altered. These breaches not only cause immediate damage but also haunt organizations for years. Then we have identity theft. Compromised credentials allow attackers to impersonate legitimate users, employee, or system. This kind of identity theft can lead to fraudulent transaction, unauthorized changes, or even sabotage of internal process. It's like giving someone a fake ID that works everywhere. Then we have financial losses. The financial implication of secret leaks are staggering. Attackers might deploy some expensive resources on your cloud account, steal funds, or cause downtime that cost customers and revenue. In some cases, direct monitoring damage runs into millions of dollars. So, next is regularity and penalties. In today's environment, organizations must comply with strict regulations, GDPR, HIPAA, PCI DSS, and more. A leak secret that exposes personal or payment data can trigger hefty fines and legal consequences. Beyond money, it can cost you the right to operate in certain markets. Then we have reputational damage. Finally, devastating impact is the loss of trust. Customers and partners lose confidence if their data isn't safe with you. Negative press and social media blacklist can destroy years of brand goodwill overnight. Regaining the trust is long and costly process. So far we have looked the risk of improper secret management. Let's see the types of secrets. So when we hear the word secrets, what immediately comes in your mind? Anyone? Anyone and have any idea like what are the types of secrets that are used in day to day? Okay, let's move forward. So, in the modern DevOps and cloud native environment, secrets come in many ways, many shapes, many forms. And each one, if exposed, can blow the whole in your infrastructure security. So, let's pick what we are really trying to protect. First is API keys. These are like digital keys to third-party services, whether it's Stripe of payment, Google Maps for your location, or send it for your emails. APIs keys give direct access to powerful system. And guess what? They are the most underrated rate limit and rarely have two MFAs. If you leak one, it's a game over for your budget and user trust. Then we have password. This one obvious but still often mishandled. Hard coded root password, database admin account, app logins. We will find them in GitHub reports. What worse, they are often shared by multiple systems, which means once your system is compromised, the attackers get master key to your system. Then comes the tokens, auth keys, JWT. Tokens are like a modern session managers. They may not look sensitive, just some base64 encoded blob, but they often carry a user identities, permissions, and session state. A leak token can impersonate a user or even an admin. And unlike password, user don't reset tokens. They just give work until they expire. Then we have TLS SSL certificate. These are like a private key, which needs to be in private. Once leaked, attackers can perform man-in-middle attack, impersonate your site, or steal your user data. Certificates with long validity period are particularly dangerous if not monitored. Then we have cloud providers credentials. Like if you take nothing else from this talk, remember this leaked AWS secret key is a security emergencies. It can be used to spin VMs, read databases, download backups, and cost you thousands of dollars in hour. Cloud credentials should never live in code or flat config files. They belong to secret manager. Next, we have database connection string. These are the triple tweet. They include server IPs, port, username, and password all in one. If they get into your logs or error messages, you just give them attackers everything they need to siphon your data. Next comes encryption keys. This is a crown jewel. Encryption keys protect your sensitive data, financial health record, and user info. If someone gets this key, they don't need to hack your system. They just read encrypted file like a plain text. This is why we isolate, rotate, and monitor keys like our life depends on it. Then comes internal service credentials or encrypted keys. Lastly, the most overlooked, the credentials that let your microservice talk each other. In the background, these are often static, hard-coded, or and reused. And if breach attackers can move laterally inside your infrastructure without detection. So these are the basic types of secret that we have covered. Next, secret lifecycle. So just like software has a lifecycle, secrets also have a lifecycle. If we manage secret without lifecycle, without understanding lifecycle, we are simply reacting to a problem instead of preventing them. So let's walk through this lifecycle stage by stage. So first is creation. This is where a secret first comes into existence. Maybe it's an API key is generated by a cloud provider or password created by a script. The key question here is who or what creates the secrets. In modern environment, this process should be automated and traceable. So you always know where secret came from, and no one's generating random credential in Slack. Then comes the storage. This is where most people drop the ball. Secrets should never be stored in plain text or sprinkled across the config files. They belongs to encrypted or centralized system like HashiCorp, Vault, secret managers are there. So storing them in GitHub, even in private repos, uh, it's an kind of security happening. Then comes the access. So always provide least privilege access. Now that your secret is stored, who get access to that secret? This is where the least privilege becomes critical. Only the right process team and a user should be able to fetch a secret, and only for shortest time necessary. Next, we have rotation. Secrets are tattoos. They aren't meant for to last forever. Regular rotation limits damage. If secrets are compromised, secret can be compromised. Think of it like changing your ATM pin regularly. If not, and if someone saw your pin, it's like inviting disaster. Most of the cloud services allow automated secret rotation. Use it, automate it, and build it into CI/CD pipelines. Next, we have deletion. When secrets is no longer needed, kill it. Maybe it was for retired service or temporary developer environment or an expert token. But leaving old secret lying around it like leaving spare keys under your doormat. So this is the small secret life cycle that we have discussed. Next, we will see a closer look into the modern cloud native environment, basically containers and Kubernetes. How without proper secret management, they can also leak credentials. So let's move ahead with containers. So I mean, in containers, we usually deploy applications, but they open a new security trap, especially around secrets. First, never bake secret into Docker images. Imagine you build your app and include database password in your image. It seems harmless, but once you push that image into a registry, anyone can pull it, or who hacks into your registry has access to that secret, and you can't just delete it. Images are immutable, and older version will always exist. It will be in your cache or backup. So even if you change the secret later, the old one still lingers in that image forever. Next is avoiding secrets as in plain environment variable. While convenient, environment are easily exposed if your container crashes or logs its environment. Guess what? The secret is now in your logs. Even worse, some process inspection tools or CLI command like ps docker inspect can show these variables. And lastly, we have containers. Containers, it can log your credentials. Your credential can be logged into secrets if they are not properly handled. So I mean, the containers are fast and portable, but it's in the risk. Secret stored poorly in images or as environment variables like in landmines, silent, invisible, and potentially catastrophic. Treat container as an inferior, but design secret handling as if it's permanent, because the leaks can happen anytime. So let's talk a little bit about Kubernetes. As we all know, Kubernetes is a powerful platform tool that can either be that can be a best ally or weakest link in secret management. For Kubernetes comes with native secret object, but here is a catch: they are only 64 base encoded by default. That's not an encryption, we can say. Just anyone can access the cluster and can decode that value in a second. That's why the first step is enabling encryption at rest within the Kubernetes control plane. This ensures that even if someone gets access to your etcd store, the place where secret lives, they can't easily read sensitive data without encryption keys. Next, we'll talk about RBAC, role-based access control. RBAC is your gatekeeper. It allows you to define exactly who or what can access your secret. You want to be extremely strict here. Think of secret as your vault. and you wouldn't give the keys to just anyone. For example, don't let all service account in the namespace read secret access by default. Instead, apply least privilege policies. So only the exact pod or user that needs a specific secret can fetch it, and nothing more. Next, we have external secret managers. This is where the real security maturity begins. Native Kubernetes secrets are fine for simple use cases, but for complex and scalable environment, we would like to use tools like HashiCorp Vault, which give a dynamic secret, and it also provides an automatic expiration rotation of the secrets. And there are other tools as also allow like sealed secret by Bitnami and cloud native managers like AWS secret managers is there, Azure Key Vault is there, GCP secret managers are there. They easily can be integrated using, I mean, they provide an integration with your clusters. So let's now we have understood the types of secret and building major roles in containers and Kubernetes. Let's explore like how to build a strong, secure secret management strategy. And I mean, this is one which protect your organization from breaches and also enhance availability and support modern DevOps workflow. So here we have dedicated secret managers. To manage secret effectively, it is crucial to use dedicated secret managers. Like we have HashiCorp Vault, which is a powerful option. It provides secure storage of your sensitive data, dynamic secret generation, fine-grained access control. And for cloud native environments, like AWS, we have our AWS Secret Manager. For Azure, it's Azure Key Vault, and for Google, we have Google Secret Manager. And here we have a small Python example using HashiCorp Vault, showing how you can retrieve secrets securely without hard coding them. So by leveraging these tools, secrets are handled in safe and centralized and efficient way, which reduce the risk of improving operational integrity across your entire infrastructure. Next is hard coding secrets in code. One of the most critical best practice is to never hard code secret directly into your files, which are shared, pushed to version control, or even accidentally exposed. Take care of secrets with them. Instead, we can use environment variables or which isolate secret from your code base, or we can use configuration files managed by libraries like .env, which allows flexible and secure loading. Here we have a quick Python example using .env. Approach keeps your application secure, easier to maintain, and safe from accidental exposures. And these are still flexible. Then, as securing our CI/CD pipeline, secret plays a critical role during deployment, testing, and cloud authentication, especially in CI/CD pipelines where automation is key. To keep your workflow secure, it's essential to inject secret dynamically, not to hard code them. Best practice, we can use trusted runners or secure environment configurations. For example, GitHub Action allow you to reference secret safely, like as shown in the given example. This keeps your secret out of the source code while ensuring your automation remains secure and seamless. So we can say the bottom line is proper secret handling in CI/CD is not just a security best practice. It's what makes scalable automation safe and reliable. Then we have automatic secret rotation, which is one of the most effective way to enhance security and reduce human errors. Why to rotate secrets? It limits the blast radius in the case of breach. It ensures compliance with industry standards and regulations. It strengthens your overall security posture by reducing static exposure time. Tools like AWS Secret Managers make this seamless by handling secrets rotation automatically and securely. Here is a quick Python example using AWS SDK. With automated rotation, you reduce the manual errors, which lowers the risk and makes secret lifecycle management smarter and safer. So let's look a brief on like how we can enforce secret policies across environment. At this point, we know that how to store a secret or use secret, but what keeps them safe across team, tools, and environment? This is where policy enforcement become a non-negotiable. Because even with the best secret manager in place, human errors or bad practice can still sneak in and cause massive damage. So first, no hard-coded secret. So, I mean, this is the number one rule and yet the most frequent broken one. Developers often hard code secret for convenient, especially under time pressure, and then forget. The solution is to automate scanning using tools like Git Guardian, SpectreLogs, or Trufflelog. These flag secrets in real time and even scan historical commits. Next, we have audit and monitoring. Secrets aren't just static piece of data. They are used, rotated, and then accessed across the stack. So we need to set up an audit log, track every access event. This helps you answer crucial questions in the time of breach. Who accessed the secret, when, from where, and why. Without this visibility, you are flying blind in the storm. Then we have automated policy enforcement. So, I mean, it's like adding pre-commit hooks to your developer's local setup so that the moment it tries to commit a secret, the commit is blocked. And the use of RBAC to define exactly who gets what kind of access. And then applying strong storage access is same as RBAC. And then I mean, just in time is like a temporary access, providing temporary access to the secrets instead of having permanent access. Users can request temporary access and it expires automatically. I mean, it's like live for 1 or 2 hours, we can say, which drastically limits the blood radius of the account that are compromised. So yeah, these are basic things that we need to keep in mind. And next we'll see a small demo. I mean, it will be a very small demo. We are just going to scan some of the GitHub repositories to find the leaks. And we'll be using a tool called Trufflehog, which is a powerful tool that scans your code repositories to detect secrets and sensitive data. And it can catch the exposed credential early so that it can be fixed before it becomes a security risk. So let's jump to my terminal. I'll be sharing my terminal in some time. Okay, so 1 minute. Let me open my terminal. Okay. So Trufflehog. So Trufflehog is a tool. I mean, it's a scan tool. It's an open source tool. To install Trufflehog, we have to simply use command. If you are using Mac, we can simply type like view install Trufflehog. It's going to install Trufflehog for you. If you are using any other Linux architecture like Ubuntu or yeah, CentOS, any other architecture, you can simply use Gemini or apt-get install Truffle. And if you have Python, it's simple. We can use pip install Truffle. So once Truffle install, it gives us a list of commands, list of parameter that we can have. So let me type Truffle. So we can see here, Truffle can be integrated with Git, your GitHub repositories. It can integrate with GitLab. File systems are basically, it can scan the files on a local system. It can scan the files on your S3 bucket, GCS bucket. It can integrate, it can scan your Docker images if you have committed any secrets by mistake. And others tools are also available, like Jenkins is there, Hugging Face. I mean, basically in Gen AI. So let me just give you a simple example to scan a Git repo. So here is a small command to scan your GitHub repositories for any leaks. So here we are using Truffle Git. We are going to scan Git repositories. This is the URL that we have given. And within the Git repository, this is, I mean, you can give any folder name or repo name. Here we have result as verified and unknown. So verified secrets are those that Truffle has confirmed as an actual secrets, like APIs keys are there, tokens are there, passwords are there. That appears in the repository's history. And the next one is unknown. So unknown secrets are potential secret that Truffle has flagged because they look suspicious. For example, like high entropy strings are there, but these haven't been confirmed as in real secrets. So these secrets, I mean, in the case of unknown, we had that you have to define it whether it is can be considered as a secrets or not. So if we execute this command, so it will generate the result as shown in the terminal. So these are the verified results, as you can see in the terminal, and it has shown us that it has AWS keys. I mean, the type of secret is AWS. This is a decoder type, that is, it is in the plain format. This is the keys which has been committed. And if you want to see the commit ID, it will give the commit ID as well as the username who has as well as the user, as well as the email address and the username who has committed that particular keys. So these are the list of all the I mean, we can say the list of scan result that we have seen here. It can be URI, whatever data we have given. And Truffle can also be used while scanning whenever you raise an pull request and you want to scan that pull request. If any developer has committed any secrets, APIs keys in the pull request. So for that we have command. This is Truffle GitHub. This is a report. This is a sure commit, and this is the PR commit. So this command is basically going to scan your pull request. And if you are executing this command, it will give the list. I mean, the result will be same. It will give the list of verified and unverified results. So it's the same result we are seeing in the AWS. But here, one more result is there, which is unverified. So we are seeing here as an unverified result. Though these Truffle has identified as a secret, as a leak, but still that we have to decide whether it can be considered as a leak or not. So in same way, I mean, it can be integrated with your Jenkins URL or S3 buckets or anything that you want to scan it. And even if you want to get the output in the JSON format, we can simply use command like -JSON. It's going to put your all result in JSON file. So yeah, this is the small demo for truffle. It is widely used in one of the, I mean, most of the organizations to track the GitHub repository. As we all know, once the, I mean, APIs keys or any secrets is committed in the GitHub, it will be, I mean, it's impossible to delete it because it can be found in the revision histories or anywhere. So, yeah, this all with the demo. I'll be moving back to the slides. Give me a few moments. My screen is visible again. Okay, so this was a small demo. And then, I mean, we can, in addition to Trufflehog, there are several powerful tools available that help us to, for, I mean, maintaining the secret management protection. Tools like we have Checkpoint, Git Guardian is there, CyberArk is there, Doppler, then what we have already discussed, and that provides and offers a comprehensive solution to detect and manage and secure your secret across development lifecycle. Each of these tools brings unique feature to strengthen your security and secret handling. So you must all try these tools as well. And then yeah, we are moving to the end. So to wrap up, let's be clear, like managing secret securely isn't just a technical necessity. It's a core pillar of proactive secret and risk management. By adopting robust secret management strategies and using purpose built tools, we reduce, expose, and maintain compliance and safeguard critical infrastructure. Automation and continuous monitoring aren't just optional, they are very essential for staying one step ahead of evolving threat. So we can say that, I mean, secret management is not a one-time task. It's a culture, a mindset that should be embedded across DevOps workflow. So thanks for your time, and I'll be happy to take questions. Thank you.
Hey, hi, Rohit. I have a question.
Mhm.
So, how often should secrets be rotated, and what's the best way to handle secret rotation in a CI/CD pipeline?
I mean, in general practice, I mean, we usually have 30 days to 90 days for secret rotation. And I mean, the best way to handle a secret rotation in CI/CD pipeline is to automate it. And tools like AWS Secret Manager, HashiCorp, these provide automated secret rotation. And by default, they have, I mean, 30 to 90 days time period for rotating secrets.
Okay, yeah, thanks, Rohit.
Yep.
Hello, Rohit. First of all, thank you so much for such a great session. So my question is, what are the key differences between using Kubernetes native secrets and a dedicated secrets management tool like HashiCorp?
Yeah, good question, Rajat. Kubernetes provides native secrets and data that are base 64 encoded and that are not robust in comparison to what provided by like HashiCorp Vault is there. They provide fine-grained access controls. They provide dynamic secret management. Even they provide auditing as well. And as the in the previous question, they provide automated secret rotation as well. So yeah, this is the best to use some centralized tool.
Thank you.
Yeah, any other question?
Yes, I do have a question. Okay. So Rohit, you mentioned about this particular tool, right? Which can detect the secrets in the Git repository,
Yep,
right?
right.
Now, this is more of a detection purpose, correct?
Yeah, I
let's
mean,
say,
it's going to scan. Yeah.
yeah, yeah. Okay, my question, let me phrase my question and then you can
Yeah,
answer
sure.
it. So my question is, let's say someone accidentally deleted, someone accidentally committed the secret into Git repository. Okay.
Okay.
Now your tool is going to scan the repository and it has detected the secret. Okay.
Right.
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 Now, how you are going to handle this, right? The challenge is Git maintains all the version history as well,
So
which
I,
means,
yeah.
yeah,
Right.
go ahead.
No, I was just saying that, I mean, usually we create a branch while making any.
Uh,
So
but
whenever a
again,
developer is
yes,
trying to, yeah,
yeah, okay. Let's say even if before scan, let's say someone has, again, I mean, you are talking about I can go ahead and delete the entire branch. But again, let's say if it is already merged into the main branch, and then how you're going to handle that particular situation, how we can handle that basically, uh, because Git maintains all the version history. I can recover those commits back where
yes,
the secret was actually populated, right?
right. So I think in that case, it might be to delete a branch and we can create a new one which don't have a
No,
file
but
in that
why?
case.
Okay, but why someone will delete the main branch itself? Everyone is working on main branch. Hmm.
No, I'm saying if a developer is using feature branch, so at the pull request is going to scan the,
Understood.
but
Understood.
and it will, I mean, there are PR checks available. It's going to fail the
Yes.
build.
Okay. Okay. Got it. So you are saying that even before pushing to the main branch,
Yes, yes. Even
PR checks
before
will be
pushing
there.
yeah, yeah.
Okay.
Even before pushing it to the main branch, we have PR checks, which is
Mhm.
going to scan the repositories. So I mean, if we go to GitHub, there is an option available like we before merging to the branch, main branch, we have to follow this particular set of instructions.
Okay.
Yep.
So is there any tool available? I mean, which basically can even restrict the pushing of the secrets directly to Git repository?
Uh, any tools? I have to further dig into it to find it out if any tool is available.
Okay, okay, okay.
Yeah, I mean, this log is mainly used in our organization, so I thought to.
Yeah, yeah, understood. I mean, see, scanning is not easy. Scanning, I understood.
Yep.
DevSecOps I can implement so that no one can do it.
Yeah, yeah.
PR
I
checks are
mean,
already there,
right, right.
right? I can delete the entire branch. But question is more if it is already merged and then what we are going to do.
Yeah, I mean, this is something. Yeah,
Okay, fine.
yeah,
Thank you.
yeah.
All right. Uh, so as of now, we can, due to time constraint, we won't be able to take more questions. And the one which is need to be explored, Rohit will be. I would be sharing the email ID of Rohit and mine, so you can email us the query, and we would be more than happy to help you out. So here we go with the emails. All right. So as we wrap up, firstly, thanks again, Rohit, for sharing your time and expertise with us today. And secondly, thank you everyone who have joined today. We appreciate your participation, and we trust that this session has helped you to better understand best practices for handling secrets and credentials securing in a DevSecOps settings. And we will continue the series with more focused topics in the coming weeks. So stay tuned for updates. Have a great day. Thank you.
Thank you, everyone. Thanks for joining.